In this video, we're going to talk about something called the rational zeros theorem. And what that says is that if you have a polynomial p, the possible rational zeros of that polynomial are all of the factor p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. So in this first example, my constant term is 6. So that means p, in this case, p is a factor of the constant term. So I want to think about all the factors of 6. So that would be 1, 2, 3, and 6. And also the negatives of those. So I should go through and write plus and minus in front of all of those. It's positive or negative, 1, 2, 3, or 6. Q is our leading coefficient. That's 2. Okay, so our leading coefficient, all the factors of that are positive and negative 1 and positive and negative 2. So the first thing that you want to do is come up with a list of all your possible rational zeros for this function. So all of your p over q's. So p over q is going to be positive or negative, and I'm going to take every p and divide by every q. So I'm going to take like 1 and divide by both 1 and 2. So I'm going to get 1, and I'm also going to get 1/2. And then I'm going to take 2, and I'm going to divide by both 1 and 2. So that's going to be positive and negative 2. But also positive and negative 2 over 2. But 2 over 2 is just 1. So I'm not going to write 2 over 2. I've already got that covered right here with 1. Then I'm going to take 3 and divide that by both. So positive and negative 3 and positive and negative 3 over 2. And then we take 6 and divide by both 1 and 2, positive and negative 6, and then positive and negative 6 divided by 2. 6 divided by 2 is 3. That's already in our list. So this is a list of all of the possible rational zeros of this polynomial. Now, they are not all going to be zeros, but that is the list of where they will come from. Those are the possibilities. They should all be in that list if they are rational zeros. The way that we're going to use that is we're then going to take those numbers and do synthetic division with those numbers until we find one that works. Okay? And by finding one that works, what I mean is we want one that's going to give us a remainder of 0. Okay? So I could try positive 1. And see if positive 1 works. Then I could try negative 1, see if negative 1 works. And unfortunately, if you're not getting a remainder of 0, those don't work, and you need to go back and start again with a different number. And you could exhaust this list all the way until you get to like 6, and 6 might be the one that works, but you've tried all the other ones already. Okay, so it could get exhausting to do that. I'm going to go ahead and use one that I know is going to work to show you what happens. I'm going to use positive 2. I have this thing graphed, so I'm able to see that. But I'm going to do positive 2, and I'm going to do synthetic division. I want you to see what happens. So I'm going to do positive 2 synthetic division. Take the polynomial, which is, again, right here. Write the coefficients across the top. 2, 1, negative 13, and 6. And we're going to do synthetic division. So 2 times 2 is 4, and we add. Gives us 10, and we add, and we multiply, and we add, and we got a remainder of 0. So because we have a remainder of 0, that means 2 works. Now, out to the side, I'm going to show you what we're doing as we go through this. So we started with 2x to the third plus x squared minus 13x plus 6. We're trying to use this idea to help us factor a polynomial. So I want to break this polynomial down as much as I can to make it super simplified into just its factors. And because 2 worked, that tells me that x minus 2 is one of my factors. Okay, so this is equal to x minus 2 times what? Well, it's times what I have left over. What I have left over, that was 2x to the third. I went down a degree. It's now 2x squared. So I have 2x squared plus 5x minus 3. So what we found was that polynomial that we began with could be written as x minus 2 times 2x squared plus 5x minus 3. And you want to keep doing this until you get to something that you are comfortable factoring, or you could keep going possibly sometimes even further than that to help you out. So I would be pretty comfortable factoring this thing that I have left, this 2x squared plus 5x minus 3. Some others may not, so you may want to continue to try numbers with synthetic division. But I will tell you, when you try other numbers with synthetic division, do not go back up to the top. Okay, don't go back to the beginning polynomial, because the goal is to continue to break down the polynomial. So instead of doing that, you want to focus in on what you had left, and that needs to be your new top line with synthetic division so that you can continue to break that down. Okay, so I'm actually going to use another one that works here. I'm going to use I'm going to use -3. I know that -3 also works. -3 is in this list, so it's something that you would try, possibly. But again, I'm not going to go back to the beginning polynomial. I'm going to use what I had left over here, and I'm going to do -3. So I'm going to take -3 with 2, 5, and -3, and I'm going to break this down. Synthetic division. 2, -6, that's -1. That's +3, that's 0. There's my remainder in the last box. So again, what does that mean? Well, we have this x minus 2 out front. Because -3 worked, that means that we have a factor of x plus 3. And then what else do we have? Well, this is all that we have left now. This was 2x to the third. We did synthetic division once. That's 2x squared. This is now just 2x. So we have 2x minus 1. And I have this thing now completely factored by simply doing synthetic division twice. Okay, but I had to know which numbers to use, and those come from that list of P over Q's. It could just be a guessing game. But as I said before, like if you look at the graph of it, I knew that 2 was going to be 1 because it crosses through at 2. I knew that -3 was going to be 1. And the other one, if you think about this, 2x minus 1, if I solved that, I would get positive 1/2. And if you look, it also crosses through at positive 1/2. Okay, so I'm going to look at the next example now. The next example is finding the rational zeros of a polynomial. So we are going to list the possible zeros, all the P over Q's, and then we're going to do our synthetic division and then repeat doing that to get all of our possible zeros. Okay, get all our zeros. So the P over Q list here, the P over Q list is going to be positive and negative. Again, we're taking all the factors of 10 divided by all the factors of 1 this time. So that just means I need to list out all the factors of 10 because I'm only dividing by 1. So that means I'm going to have positive and negative 1, 2, 5, and 10. Those are going to be my possible rational zeros. Again, I want to do synthetic division here. But I'm going to graph it so I can tell which number to use with synthetic division. So I'm going to go ahead and do that. And I see that it goes through -2. I also see that it goes through 5. So I'm going to end up using both of those. Now these other two places that it crosses are not good numbers. So don't try doing synthetic division with 2.414. Okay? You want to stick with the whole numbers to do synthetic division. So I'm going to do 5 and I'm going to do -2. And it's just I'm going to do it in either order. It doesn't really matter. So if I do 5 first, 5 goes in the box, coefficients 1, -5, -5, 23, and 10. And I'm going to go ahead and do synthetic division. That's 1, 5, 0, 0, -5, -25, -2, -10, 0. There's my remainder. I'm going to continue on because I also know that -2 works from right here where I left off. I don't need to include this, but I'm going to continue on down here. Bring down the 1, multiply, add. Okay, I'm looking below this line now. Multiply, add, multiply, and add. And I also get a remainder of 0 here, so that's going to be gone as well. So what do I have? Well, that means that this has now become x minus 5 times x plus 2, I do the opposite of those things, times, well, this was x to the 4th, this is x to the 3rd, this is now x squared. So I have x squared minus 2x minus 1. And if I'm trying to find my zeros, I'm going to set this equal to 0. Now the first two are easy because I already knew those from the synthetic division part. I get x equals 5, and x equals -2. Those are two of my zeros. Okay, they're listed right here. My other two zeros come from this. And ideally that factors, but unfortunately in this case it does not. I can't think of two things that multiply to -1 and add to -2. That does not work. So because of that, we have at least gotten to a point now where, look, we didn't know how to handle this fourth degree polynomial other than using synthetic division to break that down. But what we've done now is we've taken that, and now we just have this quadratic trinomial that, if it doesn't factor, it's not that terrible because we do know how to handle finding the zeros of a quadratic trinomial, and that is through the quadratic formula. So that's what we're going to use to solve this. So with what's left, we're going to do the quadratic formula, and that's going to be that x is going to equal -b plus or minus, again I'm using this, plus or minus the square root of b squared, which would be 4, minus 4 times a times c, all over 2a, which would be 2. And I'm just going to simplify this as much as I can, and I'm going to leave it as a nice answer and not 2.414 or whatever it was on the graph. Okay, so 2 plus and minus the square root of, on the inside here I have 4, and then 4 times 1 times -1 would be -4, but I'm subtracting that, which means I'm going to add 4, so that's going to give me 8 over 2. I'm going to go ahead and simplify the square root of 8. The square root of 8 is 2 square roots of 2. And now, because I have common factors here, here, and here, I can reduce those all to being 1s. And I get that x equals 1 plus or minus the square root of 2. And those are my other two answers. So I have 5, -2, and then 1 plus root 2 and 1 minus root 2. Those are all of our answers, all of our zeros of this polynomial. Okay, so sometimes you will need to use the quadratic formula, and hopefully that is not a terrible thing for you to do because you've done it enough.